We'll go with this. Yeah, this should work. Okay. This is probably the most important part of Unit 7, what we're about to do. Not that the first one wasn't important, but this is probably even more important. The product and quotient laws of logs. I want you to try to think of what logs are. Logs are exponents. I've said that a couple of times. Think of a log of an exponent. So when you take the log of a product, all right, you're taking the log of exponents. So remember that when you multiply two things, you can add their exponents, but it kind of works the same thing when we talk the product law of logs. The log of the product of two things is equal to the log of their separate amounts added together. So the log of m times n is equal to log, if it's the same base, has to be the same base, the log base b of m plus the log base b of n. The b has to be positive, it cannot be equal to 1. The m has to be positive and the n has to be positive as well. So you can't take the log of numbers that are less than 0. We've talked about this before, right? It has to be greater than 0. The quotient law is kind of what you expect it to be. If I'm dividing two things, just as if I'm dividing two things that have the same base, I would subtract their exponents. If I'm taking the log of a quotient, then another way that I can write that is to take the log, if it's in the same base as the original, the log base b of m minus the log base b of n. The same conditions would apply, that b has to be greater than 0, and b cannot be equal to 1. The m and the n must also be positive. Okay? All right. So that's just what the law says. That's all that is. That's really all it is. Let's see if we can put that to good use now. Let's write this as a single log. We're taking, and these are all log base 5s, right? So log base 5 of 6 plus the log base 5 of 8 minus the log base 5 of 16. So let me take you back. Just remind you what the law says. If I have a product, I can write it as a sum. If I have a quotient, I can write it as a difference. The reverse is true. If I have a sum, I can write it as a product. If I have a difference, I can write it as a quotient. So what I have here is a sum and a difference. So what this means is I can write this as the log base 5, remember it has to be the same base, of the two numbers multiplied together, the 6 times the 8 divided by the 16. Okay, the numbers that I was adding together can be multiplied. The number that I was dividing, that I was subtracting, is going to be divided. Now, obviously, I can reduce this, right? The 8 and the 16, I can, let's see. This goes into this once, and this goes into this twice. This once and this 3 times. So it's a log of 3, basically. Okay, so if I, on a calculator, found the log base 5 of 6, added that to the log base 5 of 8, and subtracted the log base 5 of 16, at the end of it, it will be the same thing as the log base 5 has to have a 5 there of 3. Thank you, Alexander. So it's a log base 5 of 3. All right? So pretty simple, nothing spectacular there. Let's get to the second one, unless there's any questions on that one. Anybody okay? Everybody okay with that? All right. Sure. So at the end of it is just a log base 5 of 3. Okay. All right. So can I continue now? Are we good now to continue? Quinn? Yeah. Okay, good. All right, let's get to the next one. Now, sometimes you have to state restrictions, which we will in a minute. The log of x plus the log of y plus the log of 3x minus the log of y. Okay, so what is this equal to as a single log? Now, these are all base 10 logs. The previous one was a base 5 log. This is just base 10. Again, nothing stated explicitly means it is a base 10 log. So that means that this is the log of log base 10. I'm not going to put log base, I'm just going to put log of the x times the y times the 3x all of that divided by y, right? So these three things multiplied together because they were added together, divided by the thing that was being subtracted. Now, as you'll notice, this can be simplified. The y's cancel out. The x and the 3x, well, why don't I just make that 3x squared? So let me ask you a question then, right? I'm just going to throw this out there and see how people feel about this. And by the way, there's some restrictions on this, which we're going to talk about in a minute. We'll get back to restrictions in a minute. Can I write this? Is this the same thing as 2 log of 3x? Can I put that 2 in the front? Does that sound right to you? Is that right? Is it okay for me to do that? Let me get some opinions on that from the room. Remember that power law that we learned? Isn't the 2 just on the x, Roma says? A very good observation, Roma. If that 2 was on the outside, then absolutely we could do that. But this is wrong. What I just wrote down is a temptation you should not yield to. That's wrong, right? The 2 would have to be on both the 3 and the x for us to be able to put that 2 in the front. So Roma is absolutely right. That is not a correct reinterpretation of the original. Okay? All right, let's see. Quinn, go ahead, please, Quinn.
So you just said if there was a 2 or if they were both the terms that squared.
Yeah. So, sorry, go ahead.
What would happen to that exponent? Would only one of the exponents leave and go to the front?
No. So I'm going to write that down now. So if this had been this, then that is absolutely equal to 2 log of 3x. That's fine, right? These two things are equivalent, right? Log of 3x all squared is 2 log 3x. I get a green light on that. I use green by accident, but I would absolutely put a green light on that. That's good to go, right? The one I did before is not. And Roma said it best when she said that the 2, this exponent, is not on both. I'm actually going to erase this. So these two things are different. So Quinn, hopefully that makes sense. I'm going to go ahead now and state my restrictions here. There are some values of x and y that should be restricted. Can anybody tell me what restrictions I should place on my x and my y? What do you think, folks? Remember, the original question was a log of x, and we need to go back to the original. It was a log of x plus a log of y plus a log of 3x minus a log of y. Right? What values of x can I not use? That's what I mean by restrictions. Right? Can you think of any values of x that would be invalid? Anybody, folks? No wheels going today. Just asking the questions. X has to be greater than 0. That's true. Oh, sorry. Any other restriction apart from that? Y also has to be greater than 0. But you're probably thinking, but there's no y in the final equation. That's true. But the original had a y in it. So we're going to have to restrict it to being values greater than 0. That also has to be positive. So if you have variables in something that you're trying to simplify, then you should also look for restrictions. What values of x are not permitted? It's just like when you have a rational function and you have to restrict any values that would make the denominator 0. It's the same thing here. Except this time you have to say it has to be positive. So x must be greater than 0, and also y has to be greater than 0. Okay? All right, let's move this along. Evaluate. Evaluate. The log base 8 of 4. Now, this is without a calculator, by the way, folks. We're trying to do this without a calculator. All right? I think I told you before that when my regular day class, right, when the students are in front of me, I actually give tests and quizzes sometimes where I take away the calculator and I say, hey, you're going to have to do this mentally. I know that sounds cruel, for kids who feel that calculators should be used all the time, but I actually want you to think. So if I said to you, and I know I can't, there's no way for me to monitor that when you're not in front of me, but if I said to you, solve this without a calculator, what would you do? Well, let's just use that same thing that we just learned, that the that the product law says that this is the same thing as the log base 8 of 16 times 4. Right? That's what it is. It's the log base 8 of 16 times 4, because the product law says if I'm taking the log of two things being added together, I can sum them together. I can multiply them together. So what I'm looking for is the log base 8 of 64. Does anybody know the answer to that without a calculator? If I said do this without a calculator, absolutely it's equal to 2. Let me challenge the class, because this class is a good class. I'm very impressed with how a lot of you have done in this class. So what if I said to you, can we solve this another way? Yeah, what we just did is legit, right? The log base 8 of 16 times 4. But could we, okay, so this is one method. So let's put on the side here, one method using the product law. And my writing is awful. So one method is this. But could we legitimately find the log base 8 of 4? And could we legitimately find the log base 8 of 16? Is that even possible? And my answer to that question is yes. And I'm actually going to challenge us to do that right now. Right? What is this equal to? What's the log base 8 of 4? Without a calculator, right? Those of you reaching for your calculator right now should be saying, no, we're not going there. We're going to put that calculator aside and we're going to think this thing through. There is a way that we can figure out the log base 8 of 4. There's a way that we can figure out the log base 8 of 16. In fact, let's do this. Let's set both of these, let's solve them individually. Let's set both of these equal to x. In fact, let's set one equal to x and one equal to y. All right? And let's see if perhaps we can solve this by putting it in exponential form. Remember what exponential form is. What would this look like? And that's why I'm doing this, to give you a little bit more practice with logs, exponential form, all this good stuff. Give me an exponential form for what I have on the board right now, on the smart board right now. Instead of on the left-hand side, instead of the log base 8 of 4 equals x, give me an exponential form for that, please. Anybody? Come on, folks. You can do this. 8 to the power of x equals 4. Well done. 8 to the power of x equals 4. And on the other side, excuse me, 8 to the power of y equals 16. Let's go back to the first side. Think about what we just did on the previous slide. On the previous page. How can I solve for that x? Change the base. Thank you, Hussein. What base do you want to use on the left? What base makes sense? Base of 2. So let's call this 8, 2 to the power of 3. And then this is, of course, raised to the power of x. Let's call this 2 to the power of 2. Can we accept that? Does that make sense, everybody? Let me just check with the room on that. Okay. Let's keep solving this now. Let's continue solving this. So this is 2 to the power of 3x is equal to 2 to the power of 2. And we know that the bases are the same. So 3x equals 2 and x is equal to 2 over 3. So here's what this means. This means, let me take you back to what we were asking before. What's the log base 8 of 4? The log base 8 of 4 is 2 over 3, right? Because that's what x is. When we were setting this up, we set it up that the log base 8 of 4 was equal to x, and we solved for x by going through all of these steps. So since that's what x is, that means the log base 8 of 4 is 2 over 3. That's what it means. So we actually evaluated one part of this question, the log base 8 of 4. And we found that to be 2 over 3. Let's go to the other side. Let's do the same thing. 8 to the power of y is equal to 16. So let's make this 2 to the power of 3 again, to the power of y. And instead of 16, can I express 16 a different way with a base of 2? 2 to the power of what should give me that 16? Help me out here. 2 to the power of 4. Well done. So again, we can now say that 3y is equal to 4, and therefore y is equal to 4 over 3. So we can answer the question now. The question was, what is the log base 8 of 16? If we know that y gives us that, so the log base 8 of 16, the log base 8 of 16 is 4 over 3. Now let me take you back to the question. The question said, add together log base 8 of 4, which we said was 2 over 3, plus the log base 8 of 16, which we said was 4 over 3. So let's add these two together. We've actually evaluated the log base 8 of 4. We've actually evaluated the log base 8 of 16. One is 2 over 3, one is 4 over 3. So that means that this, add the two tops together, over 3 is 6 over 3. Guess what? That's equal to 2. We got 2 by using this method, right? The first method. But we can get 2 by actually evaluating the log base 8 of 4, the log base 8 of 16. That's the beauty of math. That's why I love this subject, right? I don't have to do everything one way. There are several ways that we can interpret a question, but we end up with exactly the same answer. We get to the same destination by going different routes. Okay? All right. I thought I'd just put that in there just to sort of tie it back to what we did before. Sorry, go ahead, please. Somebody had a question.
Can you just show that last piece of it right there
Sure.
at the bottom of the equation?
Okay, sure. Like down here?
Yeah.
Okay. So let me just show it. So I just want to write it down then, I guess. All right. Okay. All right. So is everybody following so far? We have a couple more of these to do. Just want to make sure that we're all on the same page here. Okay, let's see who that is now. That was Donna. Donna, please go ahead. No, not really. The other method is, you mean the first method or the second method? Which one? Sorry. Oh, yeah, exactly. The second method is not using the product law at all. The second method is actually evaluating the log base 8 of 4 and the log base 8 of 16, adding them together. That's exactly what we just did. Okay, you're welcome. Okay, let's get to this one here now. The log base 3 of 405 minus the log base 3 of 5. Well, that's not hard. Again, without a calculator, it's the log base 3 of 405 divided by 5. Okay? I believe, if I'm not mistaken, that that is equal to, actually, I don't know what that is. I think that's 81. I want to say 81. 5. Yeah, 81. Okay. That's mental math there for you folks. That's a little lesson for you. I didn't run to my calculator. I just kind of said, we can do this. So 81. Anyway, so here's what, it's the log of 81, log base 3 of 81. I'm there yapping away. I realized I didn't write that down right at all. That is equal to the log base 3 of 81. Okay, 405 divided by 5. So what is the base 3 log of 81? I don't know why I'm writing that. What is the base 3 log of 81? Again, that's not something that we need a calculator for. Chrisania and Roma are in agreement on that. It's equal to 4. Well done. And I'm assuming that they didn't need a calculator for either one of those things. Log base 3 of 81. What do you raise 3 to that gives you 81? Answer is 4. Okay. Let's see if we can keep this flying here. Again, using that product and quotient law. Can we actually evaluate this one, right? So I know you could grab your calculator right now and you could, start pumping away on the because it's a base 10 log, so you don't really even really need to think about this one too much. You could just say lazy man style, just take 2 times the log of 5 plus half of the log of 16, and boom, there's your answer. But we're gonna actually think this through. What's another way for me to write 2 log 5? Is there a way that I could write 2 log 5? Another way to write 2 log 5. Come on, folks, let's think about that. Think about that power law of logs in reverse. Instead of saying 2 log 5, that could be what? So I'm asking about this first one right here. Can I write that a different way? It's a log of 5 squared. Thank you, Alexa. Thank you, Christina. Thank you, Hussein. Thank you, Quinn. So the log of 5 to the power of 2. Is there another way for me to write the second one? A half of log 16. Right? Another way of writing that. Think about the same power law of logs. It's a log of, well, yeah, but you're running a little bit ahead of me, Roma. It's the same thing as the log of the square root of 16. And you're right, that is 4, but I just wanted to make sure that we didn't run ahead of ourselves. So actually, even before that, let me back up a little bit. Before you put the square root there, another way of writing it would be to say 16 to the power of a half, and that, I make this a log of 25 now, plus the log of the square root of 16, because that's what a half means. Okay, so this is the log of 5 of 25 plus the log of 4. Okay, 16 to the power of a half. Well done. Okay, now let's use that product law that we just learned. The log of 25 plus the log of 4. The log of 25 plus the log of 4. Product law says I can do what at this stage? You're both base 10. We already know that they're both base 10. So what does the product law suggest at this point? That is the log of what? According to the product law. Come on, we're using the product law here, folks. What does the product law say we can do? It's a log base 10 of 25 times 4. There you go. Which of course is 100. Which of course, I'm not going to insult you by asking you to tell me. I'm just going to say it's 2. We all know that that's 2. So if you had used your calculators and found the 2 log 5, you're going to get some decimal. The half of log 6, you're going to get some other decimal. But when you combine those 2 together at the end of the day, you're going to get 2. In exact form would be 2. Okay? If I'm going too fast, just like how you hear Donna and Quinn and Ryan and Hussein, who were the ones I'm going to applaud for, saying, can I do this again? Leanne is another one who does ask the questions. The names that are coming to me, that's not the entire list, but there are a lot of people who will stop me and say, could I do that again? And I'm okay with that. What I'm not okay with is you just sitting there, and if you don't get something, you don't say anything. That's what I'm not happy with. Okay? Let's keep going. Let's keep going. Let's go the other way. Right? This is a sum or difference. Simplify if possible. So in the first case, we're given as a sum and asked to make it into a product. Now we're given a product and asked to make it into a sum and simplify if possible. So I'm going to do the first one just to make sure that everybody understands what I'm trying to do here. That should be equal to the log base 3 of x plus the log base 3 of y, where x has to be greater than 0 and y has to be greater than 0. So it's always good for me to state what those restrictions are. This is supposed to be an O, folks. Log base 3 of x plus the log base 3 of y. Okay, so I've done that one. Give me what the log of 20 is now as a sum or difference. What is the log of 20? There's more than one way to do that, by the way. There's absolutely more than one way of doing that. Can you tell me what that might be? Okay, come on, folks. Give me one possible way of writing that. The log of 20, what is that? Equal to. Log of 10 plus the log of 10. Okay. No, not so sure about that one, Brandon. Not so sure about that one. Restate that. Log base 10 of 40. Okay. So yeah, okay. So now I'm accepting what you're saying. So log of 2 plus the log of 10. There you go. I'm gonna write down what Christiania had. So the log of 2 plus the log of 10. Now part of that we can actually evaluate. We could say it's the log of 2 plus 1. So that's one way to write it. But it did say there's some difference of logarithms, so I can leave it like that, right? I can leave it exactly like that. So instead of saying the log of 2 plus 1, I'm just going to write log of 2 plus the log of 10. Okay? All right, sorry. And Sebastian has the log of 20 plus the log of 1. Quinn, hold off a second, please. That's true, Sebastian, but at the end of the day, you're going to end up with a log of 20 anyway, because the log of 1, of course, is 0. So you're really going to end up back with the log of 20. But you know what? It answers the question to write as a sum or a difference. So that would be a sum of two things. So I couldn't give you that. That's wrong at all, right? It is two logs that you've added together. One is the log of 1, even though that's going to be 0. So you're going to end up back with a log of 20. So yeah, I accept that. Now, as a difference, I saw somebody else write as a difference. Let's see who that was. It looks like it was Roma. See, I accept what Roma says. She said, how about putting it as the log of 40 minus the log of 2? That also works. That absolutely works as well, right? That absolutely works as well. Okay, let's move on. So far, so good. Let's see. Oh, sorry. Yes, Quinn, you had a question. Please go ahead for me.
Yeah, can you scroll up quickly? Because there's I'm confused on where the plus one comes from. The log of
Oh,
two plus
right.
is that because the log of 10 is one?
Correct. Right. So I was saying that we could actually just simplify that some more, but the truth is, the question did say right as a sum or difference of logs. So we really don't need to do that. We can just leave it as the log of 2 plus the log of 10. Right? Yeah. Okay. All right. Thanks for the question. Let's move along here. So the log of a b squared c. Okay. So I've done this enough times now. Can you give me another way to write that? The log of a b squared c. Give me a sum or difference that would mean exactly that. All right, maybe it's time for me to start calling out people here because I see some of the same people all the time jumping in. So I appreciate that, but where's everybody else? That's the question. You know, people like Brannon and Alexa and Sebastian and yeah, those people are always jumping in. But Edmund, I haven't heard from you. Edmund, help me out here, please. All right. Can you give me any way that I could write that? The log of a times b squared times c. Can I write that a different way as a sum or difference of logs? Write that a different way for me, please. Go ahead. Log of a times b squared times c. And then, of course, in this case, because it's variables, we have to state restrictions as well. Go ahead, Edmund. And as usual, I'm a bit lost for this one. Okay. So this is why I'm saying you should be asking questions. Let me go back and look at the one we had before. Look at this one. You see the one I'm pointing to now, Edmund? The log base 3 of x plus y? Okay, look at what we said it was. It's the log base 3 of x plus the log base 3 of y. Because that's what the product law says. Okay? Now come back and deal with this one. The log, that's a base 10, I'll give you that hint, right, of a times b squared times c. Put that as a sum of logs. Go. As I'm stressing, that I want people to stop me if there's anything that we're doing that doesn't make sense. All right? So I'm just waiting on Edmund now to help me out. And the reason I'm going to Edmund is because I haven't heard from Edmund yet. I heard from a lot of other people, but not Edmund. So that's why I'm asking him now to participate. And there are other people I'm going to be going to in a second because I haven't heard from them at all today. And I'd like to hear from them. So the log base 10 of A. And again, Edmund, just so you know, I don't have to say the log base 10 because it's implied to be a base 10 if there's nothing there. So it's a log of A plus the log of 10 plus b squared is what you're saying. Why is it plus b squared? Okay. You probably meant the log of b. Okay. Or b squared plus the log of b squared and then plus the log of c. So it makes sense, Edmund, what you just wrote? And I'd probably write it this way. I'd say the log of A, and I'd probably say plus 2 log B, and then plus log C. So what would you now put as your restrictions? Can anybody help me out with restrictions now? All right, I said I was going to start calling out people, so I'm going to do that. People who haven't heard from at all. Hunayin, your time. Jump in. Hunayin, are you there? Where is Hunayin? Perfect. Can you give me some restrictions, please? Look at the original. I'll put a little box around it for you. What would you say are the restrictions on those variables? Give me some restrictions on the variables. And you see me do restrictions before, so hopefully you have been following along and you know what I mean by stating the restrictions. You can ask help if you need it, but let's hear what you got. And everybody else, just hold your fire for now, please. I'm just asking Hunayan for those restrictions. And as usual, ask help if you need it. I'm just going to repeat myself on that. Waiting on you, Hunayan. What are the restrictions? As I've said, we're gonna wait for you, but you need to tell us if you need help. Okay. So I'm gonna go back and look at a question before this one to see if you can give us what those restrictions are. I'll take you back to, let's see, no, not that, none of these. I'll take you back to this question right here. See the question? Are you paying attention here, Hunayan? Watching what I'm showing? Perfect. So when it was a log of x plus a log of y plus a log of 3x minus a log of y, and we simplified it, we said, okay, now let's go back and look at the original expression and see what x values we had to restrict or what y values we had to restrict. And we said, because you're taking the log of something, that thing has to be positive. All right? And therefore, this x value must be greater than 0. That's how you go to be positive. You get it positive when you say the x has to be greater than 0. The same thing happens to the y. The y also has to be greater than 0 because you're saying that you're taking the log of y. So that also has to be positive. I'll take you back to the first page when it says that if you're taking the log, when you're looking at the product law and the quotient law, that your m and your n, these two things here, have both got to be positive. So that's why we're putting a restriction on the variables. I want to come back to you now, Hunayin, and ask you, oh, sorry, wrong page, and ask you, what restrictions should I put in place for this? Okay, I hope you're going to write all of this down as we go along. All right, so your turn, over to you. What restriction should I place on this time? It's log of A times B squared times C. Did what I just showed you before make sense, Unayan? The previous page? Okay, good. If you need me to show it to you again, I can do that. X must be greater than 0. There's no X here. There's an A and a B and a C. So there's no X and there's no Y here. Let's try again. Use the variables that are in the question. Okay, so you're saying A must be greater than 0, B must be greater than 0, and C must be greater than 0. I'm actually going to take two of those and say yes. A must be greater than 0, and C must be greater than 0. Not so sure about the B. Anybody tell me why I'm saying, even though you always go back to the original equation, right? Actually, you know what? I'm going to put it in because the truth is that at some point you might say, well, if you made it into 2 log B, then that should also be greater than 0. So I'll take the B as well. Why were you thinking I was hesitant to put the B as having to be greater than 0? If you go back to the original equation, right? Not just Hunayn, but everybody else. Not just Hunayn this time. Why do you think I was kind of going to say the B because B was being squared, right? There you go. So even if it was negative, it would become positive. But you could argue, because I think in the book they give the answer as this way. You could argue that, yeah, in the original, it may have not been a restriction, but when you write it out like the way we're writing it out now, like the 2 in front there, then it means that at that point it becomes a restriction. So I guess you could make that argument. Let's move on. Okay, last question that we'll do today. Last one. The log of u times v divided by the square root of w. Thank you, Hussein, and thank you, Brandon, by the way. I can always depend on you guys. I appreciate that. All right, so let me go to another person who hasn't said much for us today. Shiabun, where are you? Shiabun, are you there? Great. Okay. So help me out now, please. Can you put this into some kind of a sum or difference? Then I'm going to ask Thomas to help me with some restrictions as well. So Thomas, another person I don't think I've heard from much today, but let's start with Shiabun. Shiabun, give me as a sum or a difference, please. Do we need any help? If you need any help, you just ask. And we can certainly take you back and look at some questions from before, but let me know what your answer is, please. So u times v divided by the square root of w as a sum or difference. What do you think? And remember, you can't just sit there. If you need help, you need to say that. And I'm quite happy to help you out. Okay. So did you look at the question that we did before this, Shiabon? Let me take you back to the question we just did, questions that we've just done. See what, not Hussein, it was Hunayn did a few minutes ago. All right, I'm going to take you back to what he did. The log of A times B squared times C, because of the product law, is a log of A plus the log of B plus, because you're multiplying, plus the log of B squared plus the log of C. Okay? Let me take you back to a question we did for division. So I can find it quickly. When it was the log of 4 or 5 minus the log of this, we could make it as a quotient, right? So we could change that difference into a quotient. So let me take you now to this. Can you give this to me as a sum or a difference, please? U times V divided by the square root of W. Back to you, Sheobon. I'm not letting you off the hook. It's your question. Did you understand what I just showed you? Does that make sense, what I just showed you? Okay. So let's see. Log of uv minus the log of w squared. No, I think you can do more than that. I think you can do more than that. See that u times v there? You're on the right track, but you're not quite there yet. That u times v, you can do more with that. So do some more with the log of u times v. Take that u times v and express it a different way. Using that product law. Okay, good. So it's the log of u minus, sorry, plus the log of v minus, now you had log of w to the power of 2. I disagree with that part. How else can we express that part? Minus the log of what? See if you can fix that. 2 log w? No, because it's a square root. If it had been w squared, I would agree, but it's a square root. What's an exponent that means the same thing as a square root? And we're running out of time, but we're going to stick with you. Let's just get this done quickly before we go. What's the same? What exponent represents a square root? Again, it's a half. So why don't we say this then? We can say it's the log of w to the power of a half, which, yes, we can write as the log of u plus the log of v minus a half log w. And very quickly, just so since we're running out of time, it means that u and v and w must be greater than 0. Folks, I'm really hoping that tomorrow will be a much better tech day for me. See you all tomorrow. Have a good lunch. We'll continue this. Thank you very much, Sinduja. Thank you, Krisania. Thank you, Sheobon. All right, you take care now. Bye-bye.